CHOg2p is really the workhorse in our industry to make biologics. Being able to understand like mechanistically what's going on between the genetic profile and the phenotypically what we see, it's going to have a lot of high potential to impact, the medicine or the biological medicine that we're trying to make. So far, I think it's a really great program, and there's a lot of undergraduate and graduate student as well as faculty that's involved. And in the industry perspective, I love the fact that it is doing very relevant work to the industry because it's of the use of CHO cell lines, and it's very relevant to what we do.
I didn't know anything about Chinese hamster ovary cells or anything like that, but finding out that they're a $100 billion industry on just Chinese hamster cells alone was mind-blowing. And being a part of trying to lower that cost for future funding and everything is something that I'm glad to be a part of.
This is a good opportunity for collaboration to work with not only different universities, because the program itself is collaborative between different universities, but the universities themselves are getting people from other universities. So like I'm working at Tulane, but I'm from Penn State, so it's just even more opportunity to collaborate with different people. One of my main reasons for wanting to do this summer was to get to experience research, to get a better understanding of what in the future, like if I wanted to have the potential to go to grad school or go straight into industry. And it's been really helpful to get a better idea of what working in a lab and conducting research on a daily basis is like. It's been helpful in that way.
So we're trying to just see how ammonia affects the CHO cells, so let's see how they behave under like very high stresses. I was kind of surprised that they started dying so early, just because I didn't see any difference in the viability of the 0 and 30, but the 60 just died off like immediately. I learned so much. Procedures, like everyone I worked with was great. I learned about myself, what I want to do later in life. So it's helped me figure out kind of what I want to do for a career later. But it was an awesome experience, and I'm very glad that I got to be a part of it.
Oh, it's great. I mean, I think clearly it's in its infancy, but they have the right foundation together. They have great students, they have great PIs, great junior faculty. They all seem to be engaged. One of the beauty of it is, there are different parts to the project, and they're doing a really great job of connecting all the parts together. And so I think any graduates that come out of this program would have a good sense of not just what they've done, but some of the areas that are connected in the use of CHO cells to make proteins. In industry, our focus a lot of the time is really getting products to the market. And at times, we don't, we try, but at times we don't have the emphasis on understanding the basic biology of some of these things. And that's where academia comes in. And so I think if we have some real fundamental understanding of some of these things, in the long run, it will help industry. Also, this is a great training for colleagues who will eventually come into industry. So I think having an appreciation of and using really industrially relevant things like CHO cells to study, I think prepares them really well for industrial positions in the future.
Since CHO cells are so frequently used in industry to produce biopharmaceuticals, if we can better understand the instability in the CHO cell genome and how to detect it or predict when it will happen, we can lower costs of producing these drugs and ultimately lower the cost of the drug for the consumer, as well as just advance CHO cell biology. The point of today was really to get all of the undergraduate research students together that have been working for the 9 weeks during the summer, share their research, share what they've learned, as well as bring in industry representatives for the external advisory committee that can guide us and give us feedback on how we're doing with the execution of the grant. And bring in all the scientists just to collaborate between sites and between levels. I think it's gone well. Without the grant, we would still be running experiments in very small shake flasks and taking a very long time to screen clones and generate data. So with the grant, we've been able to purchase the CHOg2p bioreactor, which allows us to operate 12 individual vessels at one time, and it's fully automated. So without the grant, we would not have any of that technology. And without the grant, we wouldn't have the ability to work with Tulane and Delaware State and University of Delaware.